All right, we spent a lot of time now talking about distributions, but I want to now relate that conversation of distributions to how you should cater your distributions of data for input into a model, whether that's a statistical model or a machine learning model. So most popular statistical models are so-called parametric, meaning that they assume normally distributed inputs. So what this means is that if you have inputs that are not normally distributed, you might need to transform them toward normal. And there's a procedure called the Box-Cox procedure that you can use to do that. So I'm not going to talk about it in detail here, but you can look it up. It's good to be aware of it. For a lot of machine learning models, the standard normal is ideal as an input. So in order to adjust a distribution towards normal, you might first need to apply something like the Box-Cox transformation to adjust it from whatever shape it's in, log normal or exponential or whatever, to shape it towards normal with this Box-Cox transformation. And then after you've done that, to get it to the standard normal, you can subtract the mean, which will adjust the mean towards 0. So subtract the mean of the entire distribution, and then the mean will become 0 for that distribution. And then divide by the standard deviation of the distribution. This will adjust the standard deviation to 1. And recall that a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. A particular note here is that in neural network architectures, we can pass our inputs through something called a batch normalization layer. So these live lessons do not cover deep learning in any detail. That isn't the intention. If you want that, I do have deep learning live lessons out there, as well as the book Deep Learning Illustrated. So that isn't the focus here, but just so you're aware, you can use these batch normalization layers in a neural network or a deep learning network to adjust them towards standard normal. And then what about binary inputs? Well, you shouldn't have them go into your model as heads and tails, like you couldn't have them go in as a character string, so you convert them to 0 or 1. And by doing this, by following this process, all of the inputs into your machine learning model will be roughly around the scale of 0 and 1, and then all of your model inputs should play nicely together with the model architecture. So some machine learning models might be robust to your inputs being away from my recommendation here, but even those models will probably learn more quickly if you do follow this procedure. All right, that's it for our probability distribution focus for these live lessons. Up next, I have a few exercises to test your comprehension of what we covered.